Alright, A and B are independent events. It is further given that, so when you talk about independent events, the probability of the intersection must be equal to the product of the events, A and B. So you're given this information, then what we know is that P not A not only, we are not actually used to only, but we are used to not A or not B. We know that P not B, this thing will actually be equal to 1 minus the probability of B, and P not A, this is just a recap, 1 minus P of A. But now we have what is known as P not B, P only B and P only A. What's that? So the formulas for you to calculate these only events, so P only A equal to P of A minus the P of the intersection of A and B. This is the formula that you must know if you're not aware about it. Okay, then the P only B, so on the same thing, it will be the probability of B minus the probability of the intersection A and B. So these are the formulas that we're going to use here to determine some of the probabilities if it will lead us to use them. Okay, now I'm going to erase everything. I hope you're writing this down. Okay, now let's try to answer our question 12.11. Are A and B mutually exclusive events? We are given independent events, then they give us the information P of A and B 0.3 and P only B, they gave us 0.2 as you can see. Then the question, are A and B mutually exclusive? Motivate your answer. It's 1 mark. They are not exclusive. They are not mutually exclusive. Why? Because the probability of A and B is not 0. It's what is 0.3. So that becomes the answer. But this is how you're going to write it. So they're asking, are A and B mutually exclusive? Justify, motivate your answer. This is what you're going to do. You're going to say no. And I think you actually have the understanding of why am I saying no. No, because the probability of A and B, or the intersection, is not 0. Is not equal to 0. So that's your answer. Then 12.12. Determine P only A. So P only A, you can write that formula and see if it's going to favor us. P only A, P only A equal to P of A minus P of A and B. Then do we have P of A? We don't. We only have P of A and B, meaning it will be impossible for us to find P only A. Why? Because we have another unknown probability, which is P of A. Therefore, let's try to use this one. P, or let me just write it here and erase this one so that my work can be clear. Alright, let's start here. P only B, and see if it's going to help us. Therefore, equal to the probability of B minus probability of the intersection of A and B. Therefore, do we have P only B? Yes, which is 0.2. We don't have P of B, but we do have what? The intersection, which is 0.3. Therefore, we transpose the 0.3 to the left, it will be positive. Therefore, the answer will be 0.5. 0.5 equals P of B. Then we know now that we can actually use this P only A and see if now it will work. P of A minus the intersection of A and B. Still, we can't calculate P only A. Why? Because we don't have P of A. The only thing that we do have here is what? Is the intersection. But it's something that we can do because they told us about independent events, that A and B are independent. Maybe that might actually help us. I hope that makes sense. Alright, so we don't have this one. We only have what? The intersection. I hope it makes sense. So what we're going to do right now, we're going to use this P of B and the intersection to find P of A. Why? Because they told us that they are independent. Therefore, P of A and B equal to P of A times P of B. Then what is 0? This is 0.3, the intersection. We don't have P of A. Times P of B, we do have it, which is 0.5. Then we divide both sides by 0.5 to solve for P of A. Then P of A is going to be 0.6. P of A equal to 0.6. Now we can actually take this and substitute it here to find P only A. I hope it makes sense. Alright. Therefore, 0.6 minus 0.3. It gives us 0.3 as P only A. Therefore, P only A equals 0.3. So this becomes our answer. I hope that makes sense. Then what about B? So I think this is very, very important for you to actually watch again, rewind the video and try to understand it. Okay, we can actually continue to the next question. So the next question wanted to determine the probability of not A or not B. Not A or not B. So this OR is very important. Suppose we have a Venn diagram like this. We're going to take these ticks and we add them. Then that will be our answer. I hope it makes sense. Or you can say 1 minus the intersection. It will give you what? P of not A or not B. That's very important. It's either you can use the Venn diagram or you can use 1 minus P of A and B, of which is what I'm going to use right now. Or you can draw a Venn diagram using this information, then you add where you see the ticks. So the probability of not A or B equals, I'm not going to have space here. Let me erase this thing and start afresh. I must compress my writing or my alphabets. Okay, so P of not A or not B equals to 1 minus P of A and B. Therefore, we do have P of A and B, which is 0.3. Where is it? Yes, it's 0.3. Therefore, the answer we're going to have as P not A or B is what? 0.7. Or you can actually draw a Venn diagram. Then you add the probability of not A or not B. So here we're going to have A and B, and the probability, the intersection is 0.3. Then the probability of A is 0.3, and here it's also 0.2. Then when you add these, they're going to give you what? 0.7. Or you can try to draw a Venn diagram using the information to check if it's going to give you 0.7 when you add everything inside the events. I hope that makes sense. So it's very important, very, very important. So the task is draw that Venn diagram and see if you're going to get the same thing.